When it comes to testing MIPI D-PHY receivers for conformance, the IntrospectESP SV3C D-PHY Generator offers the ability to control every analog, voltage, and timing parameter that is mandated by the MIPI Alliance. In today's quick demo, we illustrate how this is done through the IntrospectESP software, both rapidly and efficiently. So for this demo, I have attached the SV3C D-PHY Generator to the oscilloscope, and I'm showing a view of the oscilloscope here, where I have attached lane 1 of the D-PHY generator to channels 1 and 2, and the clock lane of the D-PHY generator to channels 3 and 4. The IntrospectESP software itself has been started in its default state, so it's configured to create a color bar pattern, and the color bar pattern itself happens to be the conformance test suite, the CTS test pattern. And so by default, I've generated a pattern already. What we're seeing on the scope is a short packet that is typically used for conformance testing. And I have markers here identifying one of the parameters that I will modify here on the fly. So in order to modify parameters, I have a component here called the D-PHY parameters component, and this controls the global timers basically on the D-PHY physical layer. Every one of these parameters is a spec item that is listed in the MIPI Alliance specification. So we could go into items like the value of the SOT bits themselves, the duration of the TLPX, and so on. For today's demo, I'll focus on the THS0 duration. By default, a certain value is entered here that's in the middle of the range, basically, that's specified by the MIPI Alliance. And so the value in nanoseconds here is 145, and I'll just modify it to 345. And as you can see from the context help here at the bottom of the window, this particular parameter, THS0 duration, is specified as a linear sum of the UI as well as a nanosecond value. And this is done simply because that's how the MIPI Alliance has specified it in the D-PHY spec. In any case, I started with a default value of 145 nanoseconds, and now I'm changing it to 345 nanoseconds. I'll press enter, and then I'll just focus on the scope here. And when I click run, you'll see that everything else about the signal stayed stationary except the length of this THS0 duration. And so that's exactly what we intended to do in the demo, is we took a value of THS0 and just modified it, and we increased it from 145 nanoseconds to about 345 nanoseconds. I just moved the cursor here very coarsely, but we can clearly see that the THS0 duration has been altered. I can go back to the default state here, comes back to its original value, and then I can also modify some other parameters, for example the THS trail, which was defaulting at 60 nanoseconds, and I can just modify it to 160 nanoseconds. And so again, everything else stayed stationary, but the THS trail itself now has been modified to a very long value. Every one of these parameters is controllable with high precision and accuracy, as well as other parameters such as jitter injection and clock skew as well.